and hello everybody watching on YouTube right now or later. My streams are saved on YouTube channel Errichto 2. I will not take suggestions right now. I will start from my homework and then later I will get problems from you, but we will not do Leetcode today. Let's do some problems. I have some echo. Gone. Today we will do binarysearch.com. It's that other platform, a quite new one. It has interesting problems with short statements. And this Saturday there will be no stream. Just the next one will be on Tuesday. Shall we start? Can you take problems from Leetcode discussions post? What post are you talking about? Can you give me a link? And hello guys watching on YouTube. Saraj, Abhinav. I don't think I have a help command. Maybe I have commands. Yeah, I have commands. Maybe commands help should be also should run commands as well. Good evening, Coding Gym. Welcome back. Yeah, that's enough waiting time. Let's start. Which templates do you use for C++? You can see any of my submissions for that. And yes, it is a real background. Actually, I appeared in a screening test. I posted the problems there. Well, but still, you should give me a link now if I was to see it. But today I will not take suggestions from Leetcode. Let's start with this. There will be design parking system and preimage size of Factorial. I'm not sure about this easier problem. As I said a week ago, I will also talk about a possible harder version, some kind of follow-up, because if this is just big, medium, small and they fit their own size, it's a very boring and easy problem. Like this is something for beginners who have just learned programming. In Twitch, the link command should now work. Let's see. Yep, it does. Design a parking system for a parking lot. 3 kinds of spaces, big, medium and small. And we have this initialization. So I will decrease the size of my face. This should still be enough. Yep. If we just are to believe the statement, I mean, if we are just to follow the statement, we have a constructor where we are given information about how many big, medium and small cars will come here. And then there are queries. If car type is 1, then it means big, medium or small respectively. So the solution for just this problem is to save those big, medium and small, to make those attributes of a class. Here, let's try to do it in a way that you can use in any language. You can just grab those arguments and do it like that. There are better ways to do it. It is possible to avoid underscores, but I want everybody to understand. Yeah, do it like that. And here, if car type is equal to 1, so if it's a big car, if big is at least 1, big minus minus and return true. Otherwise return false. And you need 2 more ifs for car type being 2 or 3. That's very easy. They just say that you put big car in big slot. But I told you a week ago, this is not a global variable. This is just a variable within a class, not global. A class should have some attributes. It can have values. Otherwise, like, you cannot remember anything between running functions. Okay, so what if the problem is a bit more difficult, and this is what I mentioned a week ago. So what if we say that small car takes 1 slot, medium takes 2 slots, and hard takes 3 slots. Now, if there is, I keep thinking about easy, medium, and hard problem as if it was a programming competition. Big takes 3 slots. Now, when a big car comes, it can take 3 slots, like small slot plus a medium slot. Similarly, medium can take 2 smalls, stuff like that. And can this still be done? And I think it will turn out that if we make it difficult enough, this cannot be done and it cannot be done online if you don't know future queries. If car type is of... Okay, if this is a big car, then we have a choice between taking a big slot or else if it can fit in medium and small, then medium minus minus, small minus minus, and return true. And finally, else if small's at least 3. Let's draw this as well. Where am I here? I wanted to show you the code, not the statement now. So we are focusing on this part. And yeah, we just imagine that there is some parking space. And when there is a small car, it just takes a single slot. But if it's a medium car, it takes 2 slots. Big car would take 3 slots. And now we say that this would be a small slot. Maybe this is a medium slot, big one, medium, and so on. Maybe we can, let's say that we can rearrange them. That if you need to take, something should park like in, let's say there are 2 small slots at the very beginning. It is okay to say that the first car takes this slot and those, and the medium one, and the second big car would come and take this and that together. It's fine. Let's say that the order of slots in the parking, it doesn't matter. Okay, what then? Is this correct? Is it correct to greedily say that a big car should first take a big slot, so something like this of size 3? We can write sizes next to every slot. Those are small, medium, big, medium. And here I'm saying that if possible, take the 3. If not, take 2 and 1. If not, take 2 3s. Why is it better? Why maybe we should take this one instead? And here I would need if car type is equal to, then some similar logic. This is medium, so you take medium. Otherwise, try to take 2 smalls. Minus equal to, return true. So already see that there is a lot of repeated code. And during a coding interview also your style matters. So I would suggest to change this into an array of size 3, where we have the number of slots. So maybe this will be something like that, maybe with a more meaningful name than just ARR. And this should be a function. Well, I'm proposing the following function. Take. Okay, maybe this, maybe we can modify that. take will try to take that many slots and will return true if that's possible. So if array of 0 is at least A, and array of 1 is at least B, and array of 2 is at least C, then subtract and return true, otherwise return false. This is still possible with our variables big, medium, small, so it's your choice which one you want to go with. Just right now ABC, we need a comment here. We need a comment to say what is the order. I would say that let's go with small, medium, big. Like that, so this I remove. And just takes the number of small slots I'm trying to take, then medium, then big. And then this changes to arrays equal small, medium, and big. And instead of a lot, so many strange ifs, I will say if car type is 1, then if take of 0, 0, 1, or take or of 1, 1, 0, this represents one small and one medium slot, or take of 3, 0, 0, let's make this bigger, like that. If this, then return true, otherwise return false. Much better. Try to take big slot, otherwise medium and small, otherwise 3 smalls. If it's a medium car, then take a medium slot, or take 2 small slots. And here's the thing. With this order, we try to greedily, if possible, take a big slot. Is that correct? It is correct, but you need to be able to prove something like that. If somebody asks you why it's better to take this instead of that, you need to be able to say why. And yeah, this is not right if we... Actually, this is not right if cars cannot take bigger slots. I will tell you why this code is incorrect. I think we're done here. Let's say assert false. It is impossible that we aren't, the type isn't 1, 2, or 3. Let me look quickly at chats. By the way, this seems wrong. A car can only park in a parking space of its own car type. As I said, we're solving a more interesting version of a problem. So what if the sizes corresponds to, just like I drew it, let's say that big can park in medium plus small. Let's say that small is of size 1, then size 2, and size 3. Or maybe I can write this down. We're solving a, let's solve harder version, where big slot is equal small plus medium, and also medium is equal twice small. Okay? This is what we're solving. Why is this incorrect? Well, when there is a big car, it greedily tries to take big slot, then medium plus small, then 3 smalls. And maybe this is incorrect. When you try to find a counterexample, let's try to find one where we make some decision, let's say this one, but instead this one would be better. So there is big car, and it takes medium plus small slots. And I want to say that this was a bad decision, that maybe later this medium slot is useful. Well, for whom it would be useful? It would be useful for maybe a medium car. Let's say medium car comes and it wants to take a medium slot. But now we are out of medium slots. So maybe here it would be better to take 3 small slots instead. But if that was possible instead, it means that there are 2 slots 2 more small slots. So this medium car can take it anyway. So it didn't hurt that we chose medium instead of too small. And in general, if we say that, what did I say? Medium is equal to small. It's always better to take medium and to leave too small. Too small slots can serve the same purpose as medium. And even better, but because those can only give you more than medium. Similarly, if you have a change, if you have coins, it is much better to have twice coin of value $1 or a bill instead of once twice dollar. You can do more with this. And this problem, actually you can think about this problem as just values of coins. How do you think the interviewer will feel if you told them you're solving a more interesting problem? Well, you can say that, oh, actually, I even know how to solve a harder version. And that's fine. Just first, likely, anyway, you need to go through easy version. But today I'm not going through an interview problem just to solve it, because I am teaching you something. And the skill here, important skill, also will be proving stuff. Proving why a greedy solution is correct, because this is a greedy solution. So, if indeed to leave medium slot is only worse than leave two small slots, then it's fine to do this instead of that, if both are possible. Similarly, we can say if it's always better to take big slot instead of medium plus small. Because if this big slot was to come useful later, then as well that person could use medium plus small. And similarly, if you had $1, $2, and $3, let's say that there exists a bill of $3, and now you need to pay $3, then you have a choice of leaving this or leaving that. Then it's better to pay $3 because later you just can do more with 1 and 2. That's the proof of correctness of this line. And we can similarly explain why this is possible. So after all, this solution turns out to be correct. What else can we do here? We can also say that small car can take place of medium slot, and medium car can take big slot. And then it's all about proper order. So big must take one of those possibilities. Or what about this? What if it is able to take two medium slots? Like that. Because two medium slots, it's like 2 plus $2. Just let's keep thinking in terms of bills, assuming that we have some amount. Let's say A times we have $1, B times we have $2, and C times we have $3. If we're already out of $3 bills and we need to pay $3, then maybe it makes sense to put twice $2, because maybe that's the only, like the last thing we could do. There is no other option. And maybe there are some more possibilities here. And similarly here, maybe we should consider taking a big slot, or maybe even something more. But then here, is it better to take a big slot, or is it better to take two small slots? And I think that here the troubles start. Because let's say that there is a car parking, it is of size 2, and there aren't any slots left of size exactly 2. We can choose between a slot of size 3, or here 2 slots of size 1. 2 slots of size 1, slots of size 1, this is this option, or we take 1 slot of size 3. But we are a car of size 2, it's just that there aren't any more slots of size 2. Which one is better? I think it will turn out here that it's impossible to decide. To say why it's impossible, let's There can be two different algorithms. One will choose this over that, one will choose the opposite. Then let's consider what can happen later. If later a car will come of size 3, or maybe now it's time for a drawing. If there is, and again, I don't care about the order of stuff, but let's say I have this something of size 2 slots of size 1 and slot of size 3. And I need to now decide where to park a car of size 2. And if it's here, then in a moment, what if there are 2 cars of size 1? Let's say that they just have single wheels. If one will come take this slot, then we're done and we lost. We cannot put this anywhere. I assume that one car can take only one slot. Otherwise, this problem wouldn't make any sense, because we would just take a look at the sum of lengths of slots. So that's trivial interpretation of a problem. But if one car takes one slot, and then the rest of space here is wasted, then if there is car of size 2 and then 2 cars of size 1, we are not able to win in this case. But what if, how do I mark multiple things? Maybe I can't. So what if I put this here instead? Well, then what if a big car of size 3 comes? This one. Then I cannot put it here because it doesn't fit. So no matter if this car of size 2, if you put it here or there, to take two slots of size 1 or 1 slot of size 3, it is possible that this wasn't an optimal choice. So you cannot, based on the current situation, detect what to optimally do without knowing the future. If you know the future, then you shouldn't think about this problem like this. You should do it completely different. You should think about it as a knapsack. Because then, if you know all the cars that will come, then you don't worry about their order. And if you know that there are, let's say, 20 cars of size 1, then, I don't know, 17 cars of size 2 and 6 cars of size 3, you know that it's best for those. You first can assign those to slots of size 1. If they are taken, then slots of size 2. If they are taken, then slots of size 3. And then for those, the good thing is that there are some remaining slots and there will be no cars of size 1. So it's just, we got an easier problem. We need to assign cars of size 2 and 3. And now also, and that I expect this to be easier. But let's think. If there is, while this is true, I would now go through slots. For every slot of size 3, put there a car of size 3, because it fits perfectly. That's the best you can do. After this is done, either you're out of slots of size 3 or you're out of cars of size 3. If you're out of cars of size 3, the situation is trivial, because you just need to put cars of size 2 in some slots. No matter how you do it, you will do it optimally. Because it's not that some new car of different size will come and it would need some other slot. If instead you're out of those, so now you're only left with slots of size 1 and 2, then let's use similarly this argument. For every slot of size 2, put there a car of size 2. And after you're out of this and out of this, if you're out of cars of some type, you just have one remaining type, easy. If in both cases you're out of slots of size 2 and 3, you're just left with slots of size 1. So easy again. And what we did is not really a coding interview problem, because it's, a harder version, much harder version of this problem. And in particular, the answer to whether we can do it online as a new car comes, whether we can whether we can decide where to optimally put a car, that's impossible to answer, because I showed an example where one decision can turn out bad in a moment because there will be car of different size, and the other possible decision is also bad. But if we are given the number of cars of each type and slots of each type, then it becomes a completely different problem where you can decide in advance what to put where. So you are not limited by order. And as I said, this is not a coding interview, it's just something more difficult to analyze your way of, to practice your way of thinking and proving stuff. What happens, maybe subconsciously, is that we kind of create some tree of decisions where we start here, and let's say we have here a condition. If there is a car of size 3 and slot of size 3, if yes, then we do something. If no, then do something. And you need to, with this big tree of possibilities, with this big scheme and algorithm, because, well, if you type those if-elses, you could also draw that, and this is how sometimes kids are learned, that they are taught programming. You need to just exhaust all the possibilities. A nice thing is if you can program, if you can code your program, even if you miss some case, like you didn't consider the fact that maybe there will be car of size 3 and slot of size 2, you can try a lot of random tests, and you put asserts like this one, you will find that test. Like by running your program on hundreds of random tests. Just say, if this, then do that. Else if this, then do this. Else if this, then that thing. Else assert false. If you missed some possibility, if those ifs, they don't exhaust all the possibilities out there, then assert will be hit, and your program will say, random error, this assert failed, so apparently I missed some condition. Okay, I'm done here. I'm done here, and this was an unusual one. I said a week ago, let's do this as a homework, but harder version, and it wasn't really that specified. But notice that some coding interview problems aren't really fully specified. In Leetcode, for example, or generally online, they must be. But with this more possibilities of what can happen, we are getting more into design category and some decisions and something. Oh, can car of size 2 take 2 slots of size 1? If yes, can we indeed do that optimally? It turned out we cannot, unless we know all the cars in advance. And while in coding interviews it's good to know algorithms, it's also good to communicate and to show your interviewer that you're thinking logically and you are able to prove stuff. By the way, formally, the technique of proving like that, like what I did, where instead of that, if this is not worse, this is called exchange arguments or exchange arguments technique. You can read on about it. What do you think about using test-driven development on a problem for a problem like this? Part of test-driven development is refactoring. I mean, yes, everything I kind of vomited to you here for past 10 minutes, it just creates like a series of 10 different ifs. It's sometimes good to step back and look at it more like broadly and try to simplify, connect some cases into one. Maybe to see that, oh, if instead we first focus on cars of size 2, then it's better and I don't need so many ifs, because then I'm left with just cars of 2 types, something like that. I don't think that test-driven development has that much to do here with our decisions. You need to practice being able to cover all cases without tests and without running. Leetcode problems are good for preparation for interviews, but not ideal. In particular, but maybe it's not that you should do it while preparing for coding interviews, but for example, testing and creating new problems, like in code forces, it might help too, because then you make some decisions about the problem. And yeah, sometimes problems are under-specified. And this is what you actually got as a homework a week ago. I told you that what if big can take medium plus small? And then you might get some more questions like, can big car take 2 medium slots? Or can medium car take big slot? And then problem becomes just more difficult. And basically unsolvable online without knowing the future. But still, Leetcode is quite good for coding interviews. BMW driver will take all 3 types. Maybe just parking perpendicularly to how he should do it. Let's do the second homework problem, because I don't see new questions appearing. I will update the link. This one is more standard. This is what your standard medium hard Leetcode problem, but also could be used in code forces. Let function f of x be the number of zeros at the end of x factorial. And even before reading the rest of the statement, if you ever saw something similar, you should already realize something special. It's quite easy to compute the number of zeros at the end of the number, let's say 23 factorial. It's not that you need to compute 23 factorial to get the number of zeros at the end. Because zeros, they just come from multiples of 5 and 2. Like this number, if you just get stuff non-divisible by 2 or 5, it will not have any zero at the end. 0 at the end, it means that number is divisible by 10. So it is divisible by 2 and 5. So this number, the factorial, how many zeros we will have here? Well, we have here a 5, and it can be paired with just, let's say, this 2. We have, and maybe let's start to do it as a drawing. We have a product of 1, 2, 3, 4, 5, 6. This 5 can be paired with this 2 to create a 0 at the end. 10 can be merged, actually if itself, because it's 5 and 10. Then there will be 15. It can also be merged with, just combined with any even number, and so on. Oh, there are so many even numbers that we will not run out of them. Numbers 5 are a bottleneck for divisibility by 10, so the number of zeros at the end. You might want to say that the number of zeros at the end is equal to the number of here numbers divisible by 5. Once we later get to 20, we will get another 0 at the end. But it's not that easy. Like formally, using math, if we write number x, or maybe just any number n, as 2 to some power times 5 to some power times, and now the remaining number, let's say it isn't divisible by 2 or 5, then this will have the number of zeros at the end equal to minimum of those two values. Because after transforming this a little bit, it's 10 to 8th power times, and here this is this thing multiplied by 2 to some power. But still, if this is not divisible by 5 at all, this cannot get 0 at the end. Like always, the last digit will be non-zero. It cannot be 0 or 5, because only by multiplying by 5 you can get those digits. If this, or another kind of proof, if this had 0 at the end, it would mean that this number is divisible by 5. But I said that this is not divisible by 5, and this isn't either. So we are interested in power of 2 in number n and power of 5 in number n. And with factorials, with factorials always there will be many more 2's than 5's, so we should focus on 5's, because even number appears every 2 numbers, number divisible by 5 every 5 numbers. And in Factorial, we're then interested in those numbers, but also let's notice number 25. 25 not only is divisible by 5, but actually it's 5 square. So when we wonder in this number n, actually in x factorial, how it is 5 to what power, because this will be the number of zeros, then 25 contributes plus 2 to the answer, plus 2 to the number of zeros. This one contributes plus 1, and generally everything contributes plus 1. Then later on there will be 50. 50 also is divisible by 5 squared. So the rules are that every number just like 5, 10 and so on, it gives you plus 1 to the answer. Then every number like 25, 50, 75, it gives you plus 2. And because we care about power of 5, you can maybe already guess that then we care about 5 to cubic, 5 to third power, and its multiples. Because this has 5 to third power. So this gives you plus 3 in complexity. This is how, given x, we can efficiently compute the number of zeros at the end of x factorial. We will count how many numbers of this type there are up to x, how many numbers of this type, how many numbers of this type, and we will sum this up. I will quickly look at chat for questions. No, I don't have any videos on flows, but hard algorithm topics are more frequently covered in articles, so don't try to just find it on YouTube. Let's say starting from being, let's say, yellow on Codeforces, you must be able to read hard or scientific articles. They aren't really scientific. So you don't need to do anything with 2's, right? Yes, because it's enough to kind of guess or say intuitively that the power of 2 is much bigger in Factorial. And it's indeed. For 2's, it would be that every number like 2, 4, 6, 8, it produces plus 1, but also 4 produces plus 2, 8 produces plus 3. The exponent of 2 is much bigger than exponent of 5. So this is why we focus on 5. As a reminder, if we actually computed exponent of 2 and of 5, the minimum of them is the number of zeros at the end of Factorial, because this gives you 10 to some power. And if you know that number is divisible by 10 to 8th power, it means there are 8 zeros at the end. Yes, for every next power of 5, you will get at least more powers of 2. That's right. 2's are at least twice more dense. Okay, and still I haven't even read the whole problem. I mean, I know the whole problem, but already here, you need to understand, if they tell you about some function, you need to understand how to compute it. You need to understand its properties to do anything non-trivial about it. Sure, maybe this is an easy problem, and here it turns out that you need to compute something very easy, even easier than computing f of x. But if they give you a function and they then even make the statement more complicated by introducing something more, you need to understand the first function well. Is it okay to look at solutions before trying to solve the problem? No, of course not. Like, if you looked at solutions, then it's a spoiler. What's the point of solving the problem anymore? Unless you mean, does it make sense to look at solution after some time of being stuck in a problem with a problem? Then sure, yes. You shouldn't forever try to solve one problem. If you're stuck on solving 2-3 problems in Leetcode, practice more and you will solve more problems or learn stuff. Like there is a reason why my streams are mainly solving problems and not giving you some motivational advice or some magical thing like, oh, if you want to solve hard problems, you know what? Actually scroll down and the last digit of constraints will tell you what to return in a function. No. solving hard problems is about practicing hard problems so that you would be able to solve hard problems. Okay, so if we are to implement function f, how many zeros there are at the end of x factorial, if you want to compute how many numbers divisible by 5 there are from 1 to x, like for example up to 17, you should see that there are 3 numbers divisible by 5. That's just x divided by 5, because every 5 numbers there is such a number. You can think if maybe we need to round this up or down, but this for x equal 15, we barely have 3 numbers divisible by 5. 5, 10, and 15 in x factorial. For 14, we don't have 3, we have 2, only 5 and 10. So if we just type this in C++, this will round down and it gives us correct answer. It's good like this to check for some boundary cases. Does it work for 15 correctly? And then for 14 correctly. If yes, then I'm certain it always works. We don't need any plus minus 1. This is number of numbers divisible by 5. Then number of numbers divisible by 25 is this. And you might want to say, oh, we do this. And so on. You can either list down all the powers of 5 like that, or you can make a for loop iterating over powers of 5 until, let's say, 1 billion, or whatever the limit here is. But it's easier than this. Actually, first you can think that, oh, this is incorrect, because when I said here what adds plus 1, I shouldn't count 25. So this isn't x over 5. This should be x over 5 minus those divisible by 25, or bigger power of 5. Because those add 1. Then if you want to say what adds 2, it's those divisible by 25 minus those divisible by 125. So yes, you can make this code more complicated, or you can be smarter, and you can say that every number divisible by 5 adds plus 1, then every number divisible by 25, it adds another plus 1, and so on and so on. Let's say that this adds plus 1, this adds plus 1, and now just if number is, for example, 125, it will occur once here, and once there. So we win anyway. Like we correctly said that 125, it should be counted 3 times. And yes, it will be in 3 of those lists. If number is divisible by 5 to power k, then it will occur in k lists, because it was divisible by 5 square, and so on, up to 5 to k power. So it turns out that instead of subtracting and multiplying by some big values, we just do that. And yeah, I don't want to implement this. I don't want to here create a long line that will just work with for numbers up to 1 billion, because I could here then say 625 and so on. Well, I'm a programmer. So for every power from 5 up, ans plus equal x divided by power, return ans. I don't want to worry about overflows here. Let's say that let's say that int holds infinite values. Actually, because here you should use long log. If power is 1 million and you multiply by 5, you will get int overflow. Okay, so this is just a little bit better. Okay, and now that we have some implementation of f, I will go to the rest of the problem, because they say, oh, for example, this given k, find how many non-negative integers x have the probability that this is true. So the brute force would be this: for x equal to 0, x smaller or equal at some infinity, x plus plus, if f of x is k, answer plus plus, return answer. This is obviously not the intended solution. because it's not that you should try every x. The problem is not like that. You need to smarter count this. Yeah. And they cite some examples, like for 11, the number of zeros at the end is 2. That's because there is 5 and 10. So this function should, f of 11 should give you value 2. You can check that. It's actually quite good after writing some function to just print it for some example from the statement to check if you didn't make a mistake here. The function is monotonic increasing. Yes, it is. But I will try to give you some better reasoning of why you should think that. In some problems, and I will give you another example from Leetcode as well, it's easier kind of knowing the answer, compute the input. It might seem quite strange, but given k, it isn't easy to find proper x. But given x, it would be easy to find proper k. So there are some problems where it's easier to compute the reverse. And then there is some technique we often use. Another example of that is Leetcode problem about eating bananas. This one. So maybe I will give you this as a homework, or maybe this is just whoever wants to do it. I will decide at the end of the stream. Pasting a link to eating bananas in both YouTube and Twitch. I will not cover this problem now. This is just for you for later. But it also has this property of if you knew the answer, then simulating the process is much easier. But if you don't know the answer, it's hard to do it in one way. And that's a case here. From k, it's hard to get x. From x, it's easy to get k, because we just used this. And the technique that is very useful then is binary search. Because you can binary search the answer. So the beginning of some pseudocode is this, or just actual code. We ask for some middle value. Don't worry about overflows for now. And we can compute f of x. Binary search over the answer gives you the answer and lets you check it. So this is why in this problem we should use binary search. Somebody in the chat 5 minutes ago also said a good sentence, a reasonable one. The function is monotonic increasing. Yes, that's alternative way to get the idea of the solution. F of x can only be bigger for bigger values x. And if something is increasing, you can use binary search. Those are two separate methods. You notice that something is increasing, so you can use binary search, because binary search is used on increasing sequences. Or you realize that if I was given the answer, it's easier to simulate something, it's easier to compute some other thing, so let's try to use binary search over the answer. Because given particular answer, I can check something. I can simulate anything. Okay. And does it help? Let's say that k is equal 4. I'm looking for such values x that there are 4 zeros at the end. I compute f of x, and it turns out that f of x is 7. It's too big. So apparently I need smaller values x, and smaller value x will give me k equal to 4. So if f of x is greater than k, I need smaller value x. Else if f of x is greater than k, not smaller than k, if for this x I have too few zeros at the end, I want a bigger factorial to add some zeros at the end. Like that. Okay, am I taking suggestions? Not right now. After this problem, yes, I will take suggestions, but I would like today suggestions from binarysearch.com, not from Leetcode. I want some mix. And last time we did Leetcode. And here they ask about the number, the number of x's such that this property holds. There can be a few consecutive such x's. There are two possible approaches here. One is to know already something similar, and that is, it's not that you need to know. But again, there is Leetcode problem for that. Find first and last position. I will not give you a link because my point is just this statement. Given an array of integers in ascending order, find the starting and ending position of a given target value. For example, if in this sequence 5, 7, 7, 8, 8, 10, we are looking for 8s, we say that this is first and this is last position. Maybe they cover a big segment. The way to do that is to do two binary searches. One to find the first position, one to find the last position. If this is not obvious for you, later solve this problem on your own. Or also you can read the tutorial, the solution tab. If you need to find interval with binary search, you separately find first and then you separately find last. It's not that you can do that at the same time, because in binary search you ask about middle element and you need to decide if you go to the left or to the right. And if the sequence is like that and you want to find all 8s and you ask about middle value, it turns out to be 8, you don't know if you need to go to right or to left. You cannot go to both. So no, these are two binary searches. One to find first, and then if we ask about 8, we go to the left. Like that. Okay, so I assume this is... I assume you know this. If you don't, solve this problem. But back to our factorials. Yeah, we can do two binary searches here. One to find the first such x and the last such x, that f of x is k. The other possibility is to realize something about our function. And here's lemma, or observation. Increasing x by 5 increases f of x by at least 1. This means that interval of x's for which the value is the same is small. I will give you some example values. They are not really real. I'm just saying randomish values. But let's say that f of 600 is, let's say, 180. F of 601 is then also 180, and so on. But then f of 605, well, we got a new number divisible by 5 in factorial. So it will be 181. And here f of 599, it was smaller. It was 179 or even smaller. So there are only a few x's in a row satisfying this. So it means that here you can compute it in constant time. You can do something like, while f of x, let's say, oh, okay, this will be true. This will be good. Look for everything around your value x for which we know that we got exactly k. And for each of them, just compute f of x. In my opinion, that's the easiest approach here. And we use this lemma. That it's not that the interval with same f of x will be long. I think that we're done, with exception of not handling overflows. F of x missing two part. What? Your answer is always 0 or 5? Yes, we will get to that. Later we will analyze that answers aren't just arbitrary. Like this drawing really shows it. 5 numbers in a row, exactly 5 numbers in a row, they have the same f of x. But like, whatever for now. I will fix overflows. This should be, I think, a power. Because after multiplying something of magnitude x by 5, you can overflow. Is this int? Yes, because I take x over 5, x over that. Okay, fine. Here, binary search, what is the infinity? If I want 1 billion zeros, I need number around 5 billion, because the number of zeros is around x divided by 5. So I need long longs. Then let's do everything with long longs. Int in C++, it holds numbers up to around 2 billion, twice 10 to 9th power. Let's just say, or let's use something smart. Will this be enough? 5 times k or not? Or for this number, this divided by 5 plus this divided by 25 and so on, because that's the formula here, it will exceed k, so it's good enough. I will repeat what I did here. If we're looking for such x that f of x is equal to, let's say, 12, then I say that it's enough to check x up to 60. Because for 60, f of 60 is equal to 60 divided by 5, that's 12, plus 60 divided by 25, that's 2, plus 0 and 0, 0, nothing more, so this is just 14. So yeah, this is good enough. For sure, x will not be greater than 60. It's okay to binary search up to 5k. Okay, this is then long. This is also long. It would be easier in Python. I wouldn't need to do it. Let's also assert that f of 11 is 2. If I messed up my f function, I want this assert to fail when I run code, and I will see that I need to fix that. Here remember about LL. If you just type this is an overflow. K times 5 will overflow. And here int is enough, but here long log is needed. Answer is this is enough because I just a few times do ++. Using low plus high divided by 2. This is a little bit better. Likely I explained that in binary search lecture. But if I know that I'm not close to the upper limit of type, like int type, then I don't care about it. Non-void does not return a value. Oh yeah, it warns me about that. Well, assert if I didn't find even a single x such that f of x is k, so whenever I hit this, okay, then this, but possibly run is return 0, and yeah, example is there. There is no such x. That's because when I wrote this, possibly we have a jump by more than 1. If that next multiple of 5, if it is also multiple of 25, then from 180 we would jump to 182. So 181 wouldn't have any solutions. Your input 0, output 11, expected 5. That's bad. Let's think. Yeah, let's think. For expected 5. Oh, I here have a typo. I iterate over those numbers around x with y from x minus 5 to x plus 5, but here I didn't use y. Now this should be better. Output 10, expected 5. I have one more worry, but let's say I don't know what is wrong. When I increase answer by 1, what about printing this y? In Leetcode you can just print and debug, and yeah, this is what I suspected. Negative y's are also counted, but we won't only count non-negative integers x with this property. So even though my binary search is on proper interval, I then iterate the kind of neighborhood surrounding, and I should do it like that. Max of 0, x minus 5. Like this. Run code again. Actually, f2 of 2 to 32 is just a little bigger than billion, so assigned int for binary search is enough. but it's easier, instead of analyzing exactly what it is, it's just easier to use long log. But thank you, Maxim, for a comment, because yeah, it's cool that we don't really need long log. Thanks for showing this. You're welcome. You're welcome. Yep, we solved this. The complexity is logarithmic because binary search times complexity of f. So it's log of n times whatever is the complexity of that, and that's again logarithm, because we iterate over powers of 5 until x. The number of those is just logarithm with base 5 of x. The complexity is, where is my pen? Binary logarithm of, not really n, of 5 times k, so I can say of k, multiplied by logarithm of base 5 from, well, value x, but this is also limited by 5 times k, so I will say this, and in complexity this is just a constant, we can skip it, I can just say that it's logarithm square of k, or log of k square. Just don't put this square here, that would be very wrong. That's our complexity. Because after our deeper understanding of the problem, it turns out that we are looking for such x that x divided by 5 plus x divided by 25 plus and so on is equal k, and our solution was to binary search x such that this will be true, and then inside to compute this sum we have logarithmic complexity for that. I think it is possible to skip binary search, and we will do that now just as a follow-up, but for sure it wouldn't be required in a coding interview. How to solve this if the answer is not such less? I don't know what you mean. You mean what if the answer is not small? You would need to give me the problem, because I don't know what you really want. Okay. Some alternative. Maybe we will get rid of binary search. I'm not sure if we will get rid of log squaring complexity. Isn't using assert like cheating? No, how is it cheating? I mean, this just checks the correctness. I can as well print f of 11 and see with my eyes if it's 2. I don't see how asserts are anyway close to cheating. So what? Let's try to get rid of binary search. What about that? K distinct groups is a great follow-up. Okay, thank you, Dush and Lockrobot. I will take a look, but later. Get rid of binary search in this problem. When you look at this sum, you should recognize this from math. This is geometric progression. Just like there are arithmetic sequences, like 14 plus 16 plus 18 plus 20, something like this, can be computed in constant time by taking the number of elements times the average of first and last. Similarly, there is a formula for geometric progression. To be honest, it's not that I remember that formula, I always derive that from scratch, but if you Google geometric progression formula or geometric sum formula, you will find it. Let's try to derive it. X divided by 5 plus x divided by 25 plus x divided by 125 and so on is equal to something s, and I want a formula for that. If you multiply both sides by 5, sorry, then on the left you will get x plus x divided by 5. I'm multiplying this by 5, I get x. This by 5, I get this. Plus and so on. This is equal 5 times s. And now notice that those two terms are the same. This is just infinite series. But from some point the values are smaller than 1. They are smaller and smaller, they're smaller. But if you subtract second equation from the first one, you will get that x, and those two cancel, is equal 4 times s. So s is equal x divided by 4. This is not really that precise, because in my code, I don't have this sum, I have sum over floors. So really this sum with floors, it is a little bit smaller than that. But it can be smaller by 1 only for each term, and the number of those terms is logarithmic. Like this is the first term, the second term, because maybe x divided by 5, it's like 17.9. And by rounding down, I'm losing this 0.9. Maybe also I will lose 0.9 from this, x divided by 25, and so on. So x divided by 4 would be this exact sum of this infinite series. But if you add floor everywhere, it will be a little bit smaller, but only at most smaller by logarithm. Plus that small part with smaller than 1 plus smaller than 1 over 5, this ending is very small. I don't want to prove very formally with math, but I claim that the difference between this and that will be at most logarithm of base 5 of x plus 1. This plus 1 comes from that, the ending part. So roughly we know what the sum is. So we can say here theoretically that this is x divided by 4 minus something small. But I don't really want to make this unprecise. I said that I will get rid of binary search. How to get rid of binary search? Well, if I want to get around k, and I know that from x, this sum is around x divided by 4, then to get k, I know that x is around 4 times k. Okay, or a bit more than this, plus some small value, because the f of this will be k. F of this is this divided by 4 minus something up to logarithm. Okay, so how to get rid then of our binary search? I will do this. X is equal that, while f of x is too small. And I claim that here we will only make logarithmically many steps at most. And now, if maybe this is true, or maybe this is true, f of x is equal to too big already, because we already talked that there can be a jump. Maybe a moment ago f of x was k minus 1, and now it jumped to k plus 2. It's possible. But it's still fine to do answer is 0, while f of x is equal exactly k, answer plus plus x plus plus. So if we found the first k, we just like previously, we go one by one, we know that this will be at most 5 times. But also I could just say if this is true, then return 5, because we know from this analysis here, where was that? Yeah, here I showed why the answer is only 5, because the 5 consecutive elements, they give you the same k. So no binary search, thanks to using math. What is this? Yeah, let's run and then submit. Thank you, sir. You have started proving things. I really appreciate it. I always did. Oh, and I got into a pitfall I warned you about when I said that k times 5, you need to put LL here, not to get overflow. Yeah, same here. You need to put LL. Also, it explains why unsigned int fits the answer. Accepted. Don't worry about times and the statistics here if runtime is around 0 milliseconds, because then it's just fluctuation. Even printing hello world can take like 5 milliseconds randomly because your computer decided to do something. So, but it's not that you should do this during a coding interview without proper understanding of binary search first. Let's do it even simpler. If f of x is k, return 5. otherwise return 0. Or even better, return one-liner if f of x is k, then 5 otherwise 0. Or if you want to make it even harder to understand, but now I'm just making it more stupid. This will be true or false, so 0 or 1. Multiplied by 5, it will be 5 or 0. So this will work as well. But I don't think that somebody looking at this code will understand what's going on. I'll take the binary search solution. This just got me lost. That's fine. It's, you know, a harder follow-up. Still, it isn't better complexity, because the number of steps here depends on what I talked about, what here in this difference between my formula 4 times k and the real value. And I said that because here we actually round things down, the formula isn't exact. So here we will make those logarithmically many steps by plus equal 1. Cool, done. What will k times 5 do? It will multiply k by 5. Just LL in C++ means that this is long, not int. Yep. And we got some quite cute code where it's just function f of x, and here, what, 5 lines? 6 lines, including this clause. You can even do this, while f of x plus plus smaller than k. I think after that we need to once do x minus minus, but I don't really want that. Let's not be crazy. I'm looking for questions in the chat. Are all numbers except powers of 5 possible values of k? No. Possible values of k are quite random-ish, because let's say what happens for 90, the answer will be for x equal to 90. Will be what? 90 divided by 5, that's 18. 90 divided by 35, that's 3. So it's 21. Then there is f of 91 is the same, f of 94 is the same, because we don't have new powers. Then f of 95 is this the same plus 1, sorry. It's just because this, instead of 18, we will have 19. But then finally we have f of 100, and this will be 20 plus 4, so 24. This is 100 divided by 5 and 100 divided by 25. 100 factorial has 24 zeros at the end. And as you can see here, we just got some randomish jump. It's just that 23 cannot be expressed as the sum of floors x divided by 5, x divided by 25. So it's not that for k being power of 5 or not being power of 5 there is something special. Please don't spam in the chat with unrelated stuff. Okay, we will do maybe like 1 minute break, and then we will move to this problem that was recommended to me. Why is this white? I'm quite sure that team. That's last time I used binarysearch.com, it was dark. I will fix that in a moment. Let me read the statement. If it's cool, then I will give you a link and you can read it on your own. I will just make a short 1 minute break. Counts of I represents the number of items that exist of type I. Is it a binary search problem or not? I know, the statement seems fine. So yeah, let's do that. Okay, distinct groups. Here you go. Are you going to participate in upcoming weekly round? I will not be home this weekend, so no, not likely. But yeah, I want to participate in binary search rounds. Let me fix, first of all, I do C++. Maybe just that I use dark reader. Not sure. I can put it more on the right. Strange. Yep. You can read the problem on your own. I will be back in 1 minute. Is competitive programming my full job? You can read about it here. But let's say that yes, it is. Why, Primu7, why do you keep asking about n-choose case? Somebody already answered you like half an hour ago. Use Google. Don't ask me question that when you Google exactly this question, the first result will be the answer. Never seen binary search before hearing from you. Where did you see this site? There are many possible places, but maybe series.by has it. Series.by is contest list, and I bet that they have here, they have a weekly contest. That's one way. I recently also noticed that there are some different things in series, like standings. For example, at Coder standings, they have this for the whole year, they sum up points, and the best top 8 goes to Japan. Well, they will not go to Japan this year. But series.by is a very good website for competitive programmers mainly. Be right back. Yes, no Saturday stream this week. Like, you know, Primu7, it's not that I will drop what I'm doing here with coding interviews just to answer your question that is explained in Google. That's not really good use of my time and time of all the viewers. I will get a lot of I wanted to say girls. I will get a lot of girls by this logic, by my logic. I mean, I think being smart is a positive trait. Okay, let's think about problem K, distinct groups. Number of items that exist of type I. So this input, it will mean that there are 3 items of some first type, and not to miss, when you have values already in the input and they are talking about some types, it's good not to use value as type, it's good not to use number as type. Instead, I will say that this input means that there are 3 items of type A, 3 of types B, and 2 twice type C, 5 times D, and maybe even I can list them like that. There are such 11, no, 13 items. You're also given an integer k. Return the maximum number of groups of size k we can have, given that each group must have items of distinct types. Okay, so if k is here 2, for example, my first group can be 2 and, let's say, B and D. Then the second maybe will be C and A. There must be 2 distinct letters. Their question is how many groups I can create. Then it isn't for sure true that always I can use all the characters. If the input is this, 1, 2, 8, so this would be represented by a string A, B, B, C, 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 a lot of Cs. Then I can only make 3 operations. I can remove B with C, then B with C, and C with A, and that's just 3 groups. If one number in the input is big, if it's more than the sum of remaining numbers, it is limiting a little bit. Like eventually we would try to get this number with this number. And the situation is just more complicated with k bigger than 2. The number of numbers in a single group, return the maximum number of groups of size k we can have, given that each group must have items of distinct types. For k equal to 2, it's easy to analyze. It would be just enough to say all numbers can be used, or all items, unless one value is bigger than the sum of everything else. But for bigger k, that's hard to analyze. Can we simulate this process? Because it's bad to have a lot of items of the same type. If I get this as input, 2, 3, 3, 5, I'm quite sure that it's good for me to always choose something with biggest count. I'm quite sure that for k equal to 2, first I should use one guy of this type and one of this type. So I will be left with 3, 2, 2, 4. My second operation will be removing one of those. Later maybe we can talk about the proof, but this one is more complicated. The intuition is you don't want to be left with a lot of values of the same type. It's better to distribute them. So when you have a choice between moving to such a state, or maybe removing a 2 and 2, and then having here 3, 1, 1, 4, this one seems much better because it's easier to create groups with distinct items. But this will have bad complexity. I don't think they said what is the limit for values. So those values in the input, they can be big. And if they can be big, I cannot one by one simulate stuff. That's some solution. I can implement it and just get time limit exceeded. While true, can I increase the font? I can. While true, sort, this will sort decreasingly, and after that, like the first input would just become this 5, 3, 3, 2, and I would say that the first k groups, I take them, I decrease them by 1. For k equal to 3, I would now create 4, 2, 2. Like that. I need to also count the number of operations. So answer plus plus, unless I cannot make an operation. So here, if counts of I is already 0, so I cannot take an element, return the answer so far. Otherwise, continue and then do answer plus plus. Assert for hills. Assert false goes here because it just denotes that I cannot get here. This while true will go forever until I have a return. Let's run that. Accepted for the sample test. Was there a button to copy the I don't remember now, to copy out their inputs. This and k equal to 3, it should return 2. Your result 2. Cool. But if I submit, I will get time limit exceeded, because the complexity of this is of the number of operations multiplied by k. So this is O of answer multiplied by k. It's not really that we should use answer in complexity. This should be O of something from the input. What is the limit from the input? What is the limit for answer? Well, it's limited by the values in the input. Let's call it max count. If every value is of magnitude billion, then answer can be of size billion. Actually, an alternative approach to this is every operation, but the bottleneck of program is here, the for loop over k, and here I decrease count by 1. So if I start with values 2, 3, 3, 5, I will decrease this at most twice, this at most 3 times, at most 3 times, at most 5 times. In total, the number of times I do minus minus is sum over counts of I. So this is O of n multiplied by max count. Because every time when I decrease this by 1, like this happens, and this is a bottleneck of my program. For complexity, it's enough to say what's the complexity of number of times this is run. That's bottleneck. That's my bottleneck. But here I have also sort. If k is big, then still this is n log n instead of this k. So this should be actually multiplied by kind of n times log of n divided by k, because that's how many times this is slower than that. And it doesn't look like the nicest complexity in the world, but this is what we have here. For every k operations here, I have n log n operations there. There are other ways to put it, like, well, k is in the worst case 2, and every time I will unnecessarily sort. So in the worst case, this is n times max count times n times log of n. The two n can be combined. It's this. Anyway, it's terrible. Max count can be 1 billion. I'm going through this just to teach you complexity. It's not that I'm wondering if this will pass. The moment when you see that max count can be in complexity, and they didn't say that values count of I are small, you should abandon this. You should already understand that this is too slow. YouTube chat, please don't spam. Questions about problem. Can you use okay, this is about problem. Can we use combinations and choose R? Well, the combinations will tell you what's the number of ways to choose a single group, not how many different groups you can take. I will give you some example. If from 10 items you want to choose 3, the number of ways to do it is, I don't know, let's say around 200. That's what binomial coefficient and choose R will tell you. But how many different groups you can take, like take 1, then take 2nd, take 3rd, actually the answer is 3. Like if every group has size 3 and you can use 10 different elements, the answer will be 3. So obviously it's not binomial coefficient, it's not n choose k. Sliding window. Well, sliding window is just a technique to improve quadratic complexity to linear complexity usually. Like if you have some interval and you go through a sequence once. Sliding window never lets you get rid of a big value like this one. Sliding window gets rid of single n in complexity. If your brute force isn't n squared, then don't expect new complexity to be of n after you apply sliding window. Yeah, the base of log. This came from from sorting. So, you know, if you aren't sure what this is, then you just need to read up on complexity of sorting. And in general, about time complexity. Because of this, it's not that now I need to slap sliding window here and I will have a working solution. No. For now, we just talked about simulation, and I need to come up with something completely different, or to speed this up a lot. But I cannot go operation by operation because the number of operations, so also the answer can be huge. Then what do we do instead? I believe that this problem is very difficult. I believe that this should be marked hard, at least in Leetcode it would be marked hard. Right now I know the solution only because somebody said that it's a good follow-up for our previous problem, so that's cheating a little bit. But yeah, it's very hard just now say what is the answer. And now we need to use our trick. If we are told the answer, would anything here be easier? And for now, I don't know what exactly this will be. Just like in the previous problem, it's not that after 1 second you know that if you know the answer, then something is easy. But in this pre-image of size of factorial, the answer was x, and then we can compute f of x. So here it was easier to see that given answer we can check it. Here, maybe it's possible as well, so let's try. Instead of simulating one by one, I'm looking at this, and I want to say if it's possible to take 5 groups. Actually, right now I'm not even sure how exactly we'll use this binary search. I know a different solution in n log n, or maybe no n, without binary search, but that will be a lot like competitive programming, where like we go from big values and then we do something until we hit a value very, very short for those of you who are very good at competitive programming. I think we should start the sequence increasingly, and then because every operation, assuming that k is equal 3, every operation decreases those by 1. Let's do that until those two numbers become the same. And then let's say that, okay, those values create a block. So now every operation once will take value from this, then from that. Then we repeat something until this will be the same with them, and so on. And I want in constant time to add every next value. But don't worry about it in this problem now. We want to find an easier solution. That one is tricky. If I saw this problem in Codeforces, I would just start implementing this, I think. Okay, can we now use binary search? So let's get back to this. This is the input. We have k equal to 2. And can we use answer equal to 7, for example? Can we get an answer of 7? Maybe let's make this test less trivial. If answer is 7, then we are a bit limited in using values. We know that from this 8 we will not use all the elements. We will just use at most 7 of them. From this I will use 2 elements and so on. So the number of elements we can use is the sum over minimum of AI, comma, answer. This is, let's call it S. This is the number of elements we can use. And why does it make any sense to compute that? Because it's quite easy that this makes sense, the formula. If there are 8 elements of a single type, but I only want to create 7 groups, then, well, I will use 7 of them. I claim that after we minimize every value to 7, so we will here now have 3, 3, 2, 7, I should be able to distribute all those elements. And I don't know the solution fully, so it might turn out in like 1 minute or 5 minutes that no, we cannot. I'm saying what I think this will be. What code versus rating will this problem be? I don't know. I have no idea. You can decide yourself. I tell you the solution, you tell me what is the difficulty of the problem. I don't understand all those problems. What will be the difficulty of this problem in terms of code versus rating? I cannot judge that better than you can. Don't ask me. Okay, yeah, we have those. I want to create 7 groups and I set case 2. So I want to populate 7 groups, each of size 2. And yeah, if we look, for example, at this, there are 7 Ds. I can just put one of them in each group and nothing bad can happen. 7, yeah. Then there are, let's say, two Cs. Let's use a different color for that, C and C. Then there are 3 Bs. And there are 3 As. So more or less, we did it. Maybe it will turn out in this that after we minimize every value with 7, with the answer, the number of groups we need, we can distribute those values. Can it happen though that we are out of values? Like here it happened. I couldn't use the last 3. So maybe also I need to take minimum of this. Let's maybe make this smaller. I will take minimum of this, comma, the number of groups times k. Because that's the number of slots. And I take minimum of those 2. This is minimum. This came quite ugly. I will later get back to this. More or less. And if it's indeed possible to distribute like that, then instead of going one by one, I can just compute this sum, and I can see if this sum is enough in some way. And I will not care how to distribute values. I will just say, yeah, okay, it's possible. And I will be able to say if this answer is possible. Or maybe instead of taking minimum, Control Z several times. The meaning of this S is the number of items I can distribute among groups. I cannot, if there are 7 groups, I cannot distribute all 8 items of type 4, but I can distribute 7. So I compute this. Those are elements I can distribute. And now, can I distribute them? Are there enough numbers? So instead of minimizing this with that number of slots, I check if this is greater or equal answer multiplied by k. Question mark. I check if this is true or not. If this is true, then it means I have enough elements. I can distribute them. If it's not true, if this is smaller, it means that the number of slots is too big and I have too few elements. So I cannot make that many groups. What we used here is the fact that something like this, it can be distributed into 7 or fewer groups. Into 7 groups, yeah. If every number is at most 7, we can distribute into 7 groups. And here's the proof. I don't really want to use the fact that k is equal to 2. 1, 2, 3, 4, 5. Okay, this. The height is answer equals to 7. The width is k equal to 3. So every row it will represent a single group. Now, if I have those types, if every type is of value at most 7, then I can distribute them like that. Let's say that we have 5 items of the first type. I put them in those cells. Then let's say we have 4 items of the second type. like that. Then 7 items of the third type. This strategy of distributing, and then there's one more type, and so on. If every value, if every AI is smaller equals 7, so smaller equal height of this, and it is because I minimized. I said that, oh, there are 8 items, but only 7 groups. I will use 7 of them. If this is true, then no color will get to the same row twice. Green here, I had 7 green cells. I went from this down, then through the next column, and I only got here. I cannot go more. The fact that green got here, it would mean that green is at least 8, greater than 7. This is a proof why, if this sequence has only values up to 7, it is always possible to distribute into 7 groups so that nothing could be repeated. And I showed a proper strategy here. And it's not that we need to simulate this. This is just a proof that this is possible. And because it is possible, then indeed, if this is greater, if the number of elements to distribute is greater or equal than the number of slots, this ans times k, this is just area of this rectangle. And this is the total number of cells I want to color, because it's the sum of those values. If there are enough, I can fit, so this answer is possible. If it's smaller, I have too few elements, so I cannot get this answer, and I will need to try smaller answer. And I still think that this is not medium, this is a hard problem, at least in terms of Leetcode. But indeed, it's binary search. It turned out that given answer, it allows us to do something easier. There will be at least one group, and at most sum of counts. Not sure. Let's go with int max. While low smaller equal high. If you want to know why I'm implementing binary search like that, watch my binary search lecture on YouTube. Middle is low plus high minus low divided by 2. And this is a possible answer, so instead of middle I will call it answer. And yeah, let's just implement what I had in the drawing. Sum is the sum of minimum of AI is this. For every element in counts, sum plus equal minimum of ans and counts of I. The meaning of this is, if there are 8 elements of one type, but only 7 groups, I cannot use 8 elements. I will use at most 7 elements. Now, this is how many elements I can use, and now the area of that rectangle to fill. If I own that many groups, each of size k, then it's like that. If this, then I can fill this rectangle, so I can distribute into that many groups of this size. So this is good answer. And I can try to find bigger one. Maybe more groups is possible. Return value is equal answer. This is like a global answer. And return it. Else, if this was smaller, I'm not able to achieve this answer. So I cannot make, for example, 7 groups. Then let's try 6 or fewer. The meaning of this is just, if I see that 7 is possible, I save it as a possible value, but I keep searching for a better one. Maybe, okay, 7 is possible. I'm trying to find an interval from 8 up, or then maybe later I will find that 10 is possible. I will override. Like that. Comment this out, and let's run code. The complexity is logarithm from binary search multiplied by this for loop. So this is just log of values, log of int max 32 multiplied by this log of, let's call it v. This is limit for the answer, but depends in some way on the input. I used int max because they told me to return int, so I also know that it doesn't exceed int. Multiplied by n because it's nested. Inside binary search, we have this for loop over and elements. After you explain the answer, the problem doesn't seem so hard anymore. Oh, this one was hard. Because it's hard for me to... Problem is hard if it's hard for me to say why we should go that direction. Here it's basically guessing that it's binary search. The binary searching over the answer happens if knowing the answer helps you to simulate some process. And as I said, homework for you is Coco eating bananas, because it's also a problem like this. Yeah, it will be a homework. But for sure, it's very dangerous with such problems. A lot of people, after reading editorial to this one, they will think that they understand the solution and that's it. But they will not recognize this pattern anymore in the future. Remember this. If knowing the answer makes it easier to simulate the process, then binary search the answer. The easiest in the world example of that is square root. If you want to compute without using any math functions, square root of, let's say, 71, or the floor of that, floor of square root of 71, you can use binary search, because checking if the answer is, for example, equal to 7 is easy. You compute 7 times 7, that's 49, and you compare it with 71. Oh, this is smaller than 71, so you can still go up. If instead you tried 9 times 9, 9 times 9 is 81, that's greater than 71. So 9 is too big of a square root. So the implementation of square root without using square root function in your programming language is low is 0, high is, let's say, x, square root of x, while low smaller equal high, mid is low plus high over 2. If mid times mid is too big, then we need to find something smaller, else low is mid plus 1, and also best answer, the return value from my code is mid, because this is possibly the floor. Maybe there are some compilation errors here. The point is, here, getting the answer, like if you are computing square root of 71, what can you do? But getting the answer lets you check if you can easily compute the square, you can compare that with x. So we can check if you're too big or too small. Because that's the point. Here also, we could solve the problem only because we could say if this number of groups is possible or not. If not, I can only do fewer groups. Did it with sliding window using map and the queue myself. Maybe there are other solutions, sure. I'm not saying that mine is the only one. Do they have the same thing? Can. Yeah, they also have the sum over value and take. So editorial describes the same solution. I don't know why somebody said it's greedy. Post. No, I would need to describe it. No, thank you. I mean, it's the same as editorial. Sorry, not in the editorial. Alex did in stream. Okay. That's fine. I'm not aware right now of any other solution. If you're enjoying my streams, then also for sure check out on YouTube Alex Wise. I don't know if he does Twitch as well. Does he do Twitch? If yes, you can post a link. He I do competitive programming and coding interviews. He just does coding interviews. Check him out. Okay, he has Twitch. Is Alex better than you? In coding interviews, yes, he is. You can check Errichto Leetcode speedrun. Yeah, we did, a few of us we did in 1 hour, so try to solve 30 problems, so like 2 minutes per problem. That's not really easy. And we can scroll here to see the standings. I solved 28, he solved 31, and he did it in better time. He's better by 3 problems. Also, he solved like 1,000 problems in Leetcode and 800 problems in binary search. So, you know, I solved 5 times fewer. So, even though he's yellow in code forces, he is better than me in solving coding interviews quickly. But you know, in competitive programming, obviously, judging by rating in code forces, I'm better than him. Okay, it's hour 50 minutes of a stream. Do we want something more? Let's maybe slowly. Do you want one more problem, or do we finish now? Oh, twitch.tv/AlexWise. Okay. This thing. I see. One more. Any suggestions? From binary search, if possible. From binarysearch.com. And also I can slowly choose homework. One will be Coco eating bananas. And I will need the second homework problem, maybe from binarysearch.com. Please tell us an easy trick that you really like. Do you think I remember easy tricks? Just like, you know, if you do something so many times, like let's say if you brush your teeth every morning, you don't really think about it anymore. So it's not that you are able to say how you brush your teeth. So I can't really just like that tell you an easy trick. That I like. If I see a problem, then yes, I can explain you a trick and I can say why it's reasonable to use it. But I don't remember easy tricks. When you're suggesting something, please give me a short description. Very hard graph, then I don't think it will be interesting. What is that? But I'm already guessing that this will be more of a CP problem than interview problem. Cost from and cost to. I will consider, but I want more suggestions. 3 plus DP. No, let's do DP problems next week. Largest rectangle, deceivingly similar to a well-known problem. This is the well-known problem. It's solvable with histogram, right? I mean, 250, then you don't really need quadratic. You can have cubic solution. What's the difference? Are CP problems generally more difficult to solve? Yes, they are. No, just like in sports, if you are good in one sport, you are good in the other, but not. If you excelled in one sport, it's not that you are equally good in other sports. So also, coding interviews and competitive programming, they use different tricks. And it also hurts just a little bit, but it hurts to know too much. The fact that you read a problem and you need to, in some way, check hundreds of techniques, hundreds of algorithms to apply here, it slows you down a little bit. But of course, still, it's better to practice other things than not to practice at all. to do. I'm just looking at Twitch chat, gathering suggestions from there. No, I don't want problems not from this website. You were, oh, I were to talk about the proof of why is it better to take big groups first. Too late. I don't want to do it now. Sorry. In that previous problem, what was the name of previous problem? I don't know now. No proof, sorry. It's intuitive. Left as an exercise for a reader or viewer. Well, let's read this one. Unless it's very hard. Can I see? Can from this page can I jump to contest page and see the number of submissions or like time of submitting? This is cheapest cost. Yes, it's here. Leaderboard. Okay, no, this is too hard for sure right now. Half an hour, or not, just a single 7 minutes and then half an hour and not solving at all. That's too hard. Oh, I saw douche in Leaderboard. Another graph problem. Then let's do cherry pickup, maybe. No, too long of a statement. Sorry that I'm that picky. Hard tree-related problem. Given a two-dimensional list of integers, set of disjoint trees. Connect them. I'm thinking about a solution to understand if it makes sense to do it, but no, this is not an interview problem. Damn it. Pick up gold into locations. Why are you suggesting just hard problems? It's the end of the stream. Give me something easy. This, you need to go in matrix to 2 cells, go in all directions. Okay. This is, it's not an easy problem, but I'm fine talking about it. There's also a related thing for like bigger K. I will tell you that too. This is that with a link. Rate in the end. Yeah, if there will be somebody worth rating. Do they have a drawing? They don't. They should. The problem is, there is a grid. You start somewhere. You need to grab you need to get to 2 cells. Is the order important? No. And there is gold in some 2 locations. You need to visit both. The cool thing is, once every cell has some cost, but this path might be very stupid to use, because it's good to reuse the same cell because you just pay once. The statement is bad. It's very easy to form a more natural one where it's like that. In every cell there is a monster. There is monster in every cell, and it will take, killing him will take, let's say, some number of seconds or some you will lose some amount of HP. But after you kill him, he is dead, and now you can move through this cell for free. Because of that, it's good to, after you got to 1 gold, it's quite good to get back through the same cells, maybe like this. It isn't though true that you will just like go first maybe top and right and then bottom right. It's not as easy as this drawing, because different cells, they have different costs. It is possible that optimal path will look like this, just because this is a path consisting of very cheap cells. Maybe this is the first gold, and then we go back for some time, and then from here we move there to the second gold. This is possible. Just imagine that what I drew, there are quite cheap cells and everything else has cost close to infinity. Okay, so it isn't true that we just go in direction towards the gold. Something more complicated can be true, but it can be proved that generally this could be any graph, not just a grid, but grid is also a graph where from a vertex you go to 4 neighboring vertices. If in optimal solution, if there is some path to the first gold, it maybe from that you will go to the second gold, not crossing the first path. But for sure this is not optimal. Like where you go with some shortcuts and then you visit the first path. Because if you are to get here, it's better to go like that again, because this is already free for you. Here you have some cost. Instead here it's already for free because you went through those monsters once already. So we proved that the path from first gold to second gold cannot go through some unvisited cells and then visit a visited cell again. That's stupid. That's not optimal. It can go through, though, sometime through this and then just exit from it to go towards the second goal. For the same reason as I explained a moment ago, you cannot then get back to this path, because then you would just get here. Basically, after the first path, you can go from first gold to any path, any cell on this path for free. So let's imagine that from this first X, now you can teleport for free to anything here, and from here to go to X. Or just even better, let's say that after getting to first gold, we aren't really here. We just want to find the shortest path from this first white path to the second gold, or second goal. You apply Floyd-Warshall algo twice. I don't know how you would do it, but maybe this is important. It isn't correct to first compute optimally wide path. If you just focus on this and you find optimal path from start to here, you will find optimal wide path, sure. But why is that optimal to then later also visit the second gold? I will give you a counterexample where if this is start, this is gold number 1, and this is gold number 2. Let's say that we can consider visiting them in any order, just run your algorithm twice. Let's say that costs here are 4, 4, 4, 4, 4, 4, 4, and here they are slightly bigger, like 5. And some other values here are very big, values here are also quite big, and your wide path from start to gold 1, it will find this. You will incorrectly say that you travel like that. And then from G1 you will try to find the shortest path here, and it will turn out maybe to be this. But instead it's good to consider already that gold 2 is here nearby, so it's better to go to gold 1 through a bit more costly path. a bit more expensive path, so that we could now cheaply get to G2. So it's not that we first find shortest path from start to 1 gold and then to the other from anywhere to this path. Though that would be possible. In any kind of BFS, Dijkstra, you can say that multiple cells are starting cells with cost 0, and you can run your Dijkstra or whatever from that. That's possible. By the way, yeah, the algorithm to find distances from single vertex to all other vertices in a graph, it's called Dijkstra. It isn't Floyd-Warshall. Floyd-Warshall is less effective. It is to compute distances between all the pairs. So that's unnecessary. Yeah, but the solution will be like that. I already proved why it isn't good to just find optimally wide path and hope that, yeah, as we did that, we will cheaply be able to get to second gold too. So how to think about it instead? Well, one possibility is to notice that what we create here is some way to move between those three vertices. After our both paths, you can for free move between start, gold 1 and gold 2. So I will rephrase the question. What's the minimal cost of some subgraph that would make those three vertices connected? You know how this is called? Minimum spanning tree. It's obviously stupid to make cycles. If you already cleared this, you will not want to clear that because those two cells are already connected. So this is a tree. And a tree of minimum cost combining some three vertices is called minimum spanning tree, or let's say minimal tree. And there are algorithms for that. So either you need to go in this direction of minimum spanning tree, but connecting those three vertices. Usually this is a name to say that given a graph, we want to make all vertices connected. But this is something different. If you just for a graph run this, you will find the best cost to make everything connected to each other. That's stupid. We just want to make those three connected. So no, it isn't minimum spanning tree. Unless you are able to very well understand minimum spanning tree and apply this algorithm to this problem of finding best connection of three vertices. And I see that already some people in the chat are talking about algorithm to find minimum spanning tree. Before thinking about code, you need to think about algorithm. I mean the more general idea. And MST here doesn't work. It will not find you this, because MST, no matter how you code it, no matter if it's Prim, Kruskal or Borówka's algorithm, it will find something else. But that's still one possible way. The other is to realize that the drawing will look like this. And there will be this special vertex. On this drawing, you're seeing on the right part of screen, like it doesn't really matter that this cell is exactly here, this one is here. There are three given vertices, and this one is also very, very important. I will mark it with another color, let's say blue. There will be such a blue vertex, and it is on the white path, but it also, from that, a red path grows. And obviously the red path will be just shortest path from blue vertex to X. So what if I, instead of looking at this drawing, will say that there is some big graph. Let's say that this area represents a graph. There are three special vertices: the start, 1 gold, and second gold. Their order doesn't matter. I just want to connect them. And there will be some blue vertex. It is on the path from A to C, but also B grows out, the red path goes out of that. No, B is bad because this is B. So I will name the three vertices differently. This is X, Y, and Z. The problem is, given a graph, find the smallest tree of minimum cost, combining them with each other, and there will be such a blue vertex. And we said that, well, it's something like that, right? But those three parts are independent and don't intersect. So what if I tell you that we just, for a blue vertex, we find shortest path from blue vertex here to x, shortest path from y to blue vertex, and shortest path between, the directions don't matter, so it's just shortest between blue vertex and x, shortest between blue and y, blue and z. I can iterate over this blue vertex. This way, I iterate over that special intersection, and I will say that if I want to optimally combine x, y, z, with b being the intersection, the fork in my roads, each of those three parts separately, it needs to be optimal. Like maybe it's good, instead of this shortest path, to create something here longer, intersecting with y, but that would here create a cycle. That's not optimal. If we look at this drawing and we focus on this yellow part, this one, if there was a shorter path here, this one would be better than this long one. So apparently this yellow part, it is shortest between blue and this gold number 1. And the solution is iterate over all the vertices in a graph, each of them consider as such a blue point, a fork, and if you pre-computed some distances, you will be able to ask for shortest distance between blue and y, blue and x, blue and z. The solution is, for every blue, ans is minimum of answer, and shortest distance between xb plus shortest between yb plus shortest between zb, where this denotes the length of shortest path. Initially answer is infinity. If you want, you can compute all the distances between all vertices in the graph in cubic time with Floyd-Warshall. Right, cubic time or quadratic? Cubic. But this can be done better, because we only want distances from x, y, and z. So the solution is run Dijkstra from x and save all the distances. Then write Dijkstra from y and z. X, y, z, they just denote starting point, gold 1 and gold 2. And as for, do this code. Then the whole thing is of linear times logarithm. By linear, I want size of the graph. Size of the graph in this problem is what? Height times width. Logarithm comes from Dijkstra. Dijkstra is an algorithm to, as efficiently as possible, find distances from one vertex for everything else. If edge costs can be bigger than 1. If values in the matrix were just 0 and 1, we could use BFS. That would get rid of logarithm. To sum up, we are given a graph, and there are those 3 special vertices. I want to move between them. I want to clear such a set of cells that after that I can freely move between those 3 vertices. And for that, I say that I iterate over some special fork vertex, and I say that I want the cheapest possible subgraph looking like this. And maybe the shortest path between this and that intersects with this shortest path. But this just means that the fork here would be better. And once you consider this as b, you will get better answer anyway. You will overwrite your bad answer, where in bad answer you unnecessarily computed this part twice. So this fork would be better. Are there any questions? CatBlue asks, can we run Dijkstra from start to G1 and then set all weights for the path for 0? No. 10 minutes ago I showed you why it isn't optimal to just first find the shortest path from start to G1. This was a counterexample. You want to make such a path from start to G1 that also from it the G2 is quite nearby. And here, if you take all fours, which is shorter path from start to G1, then it's more expensive to you to get to G2. So that is not optimal. And done. I'm looking for questions, but I don't see any. And that will be the end of the stream. We are now above 2 hours, and I want to keep my streams to be around 2 hours. For coding interviews, see you next time, next week, every Thursday, European 6 p.m. And I will give you homework. As I told you earlier, Coco eating bananas will be one homework problem, and I need a second one. Do you want to discuss largest rectangle next time? This will be well known to a lot of people. So maybe. This I don't want without knowing what the solution is. Coco banana is, by the way, from Leetcode, not from binarysearch.com. Dush has another suggestion. Dush has quite good suggestions, so I will consider. Is this what I think this is? Without showing you, I'm going to take a look at editorial. Oh, editorial is locked. I don't want to spoil the solution out loud, but, well, this also appears in coding interviews, right? Okay, then let's say that, yeah, it's fine. Coco eating bananas and binary search, on binary search blocks to spell word. I'm pasting in both chats. Also, it will be in Discord server and in YouTube comments. Homework for next week. YouTube. Here you go. Oh, I think YouTube is broken. It shows that concurrent viewers is 0. Well, I'm quite sure it's not 0. What can you do? Yeah, so see you next week for coding interview stream. And also, usually on Saturdays I do easy competitive programming. I just solve some easy code versus problems. This week will be different though, because I'm not home during the weekend. I will still put something on YouTube. Sonar Gonal is, as always, a valid choice. Anybody else? I'm looking for somebody to rate, and then the stream is done. What is this? Also, I want only English, but if... Okay, yeah, good. I can hit English and it will combine with my already requirement of programming. Do we see anybody doing Leetcode, code forces? Thank you for stream. You're welcome. Yeah, check out the Discord channel.
What?
Educational 3D space game. Looks cool. I hope that if I rate, he will show for a moment what he has already. Just looking at code, it's usually the more boring part. And once again, thank you everybody for watching. See you next time. Oh, no, not this.
I don't know what these mean.
How to copy this. Are you changing the value of cost after visiting X?
So anyone else that's
No,
like,
I'm not
confused?
I think you didn't understand the solution. But you can rewatch the stream on YouTube.
Where did I get those buttons from?
If a lot of people have will struggle with that, I can explain it more next stream. Okay, do your homework. See you next week, Thursday, for coding interview stream.